All right, so finally here in Chicago, we have Ananda. This is a social app for endurance athletes to find and follow training partners. They've done some interesting stuff with mapping and geospatial libraries to analyze user activity. So let's take it away, Matt.
Hey everyone, thanks for sticking with us. I'm Matthew Thor, this is Bon Davis, Rick Polidoro, and Patrick Gund. And we're here to tell you about our project Ananda, which is a social web app for endurance athletes. Ananda's purpose is to connect people who share similar passions and to help our users find new people to connect with based on their training habits. Our name is inspired by the chemical compound anandamide, which is largely thought to be responsible for the sensation of a runner's high and comes from the Sanskrit word for bliss or happiness. We thought this married perfectly with our core mission of finding and nurturing friendships.
So how does Ananda work? As user, you would start by either logging in or creating an account. Once you're logged in, you're brought to a page that shows your name, feed with your friends' activities, as well as follow recommendations, which are generated by our custom algorithm. You can also comment on and like these activities directly from this page. You can also view details of a single activity or visit a user's profile. Me and Cody go way back, so I'm going to follow him. From your account page, you can also see your statistics and update your account. Lastly, you can upload an activity, which will be displayed on your profile page and for your followers to see.
Thanks, Bond. Now, in order for these features to work, we needed to create relationships for followers, likes, comments, and what have you. Keeping track of all these relationships and making sure we have quick access to a user's followers, for instance, was essential to incorporating our recommendation engine. We were able to address these challenges with unique associations in SQLize. However, storing in GPS data presented a major hurdle because as we learned to interpret our data, we also had to figure out how to use this data and display this on a map. The Google API seemed like our best bet. However, we ultimately found that the complex geospatial functionality we required was readily available with the Mapbox API.
So how do our users get their activities on our site? In an ideal world, we would have used something like the Garmin API, but we weren't exactly interested in their $5,000 price tag to do so. So we decided to import GPX files, which is a standard file format for GPS activities, but we also didn't want to have to store those on our server. So our solution was to send the files over HTTP, parse the information from that, and store the information on our database. Now, a GPX file is just a big collection of what are called track points, as you can see here, which contain a coordinate pair and a timestamp. But we didn't want to store big arrays of data in our database, so our server actually converts that to a polyline, which is just a string, as you can see, as well as calculates relevant metadata like the center point, the start and end time, pace, and distance. This allows us to display the activities, as you saw a minute ago, and is also critical to making new friend recommendations.
Determining recommendations is a complex task. The difficulty that we face is the vast amount of data that we have to work with. Each individual run is comprised of thousands of GPS points and other metadata. Each user can have thousands of runs, and our site may have thousands of users. In order to determine if 2 users should be recommended as followers, we have to sort through this data quickly to prevent our site from crawling to a halt. As an individual user, I may have 100 runs, but for 90 of those runs, I may be running the same pace, the same time, etc. By using a caching mechanism, we can effectively turn those 100 runs into 11 runs for future comparison. We start by comparing 2 individual activities. If they match closely enough, only one of them is stored in a user's cache. Then, when a new activity is uploaded, we only need to compare that activity to the existing activities in the cache, not every activity for that user. We can then compare 2 individual users' caches against one another, and if they match closely enough, recommend them as followers. By using this methodology, we can traverse through our entire data set in a fraction of a second, ensuring a smooth user experience.
And that's Ananda. Feel free to check us out on Heroku at Ananda-Runs to start tracking your own activities and start making new friends. Thanks for listening. Happy running.
All right, if you'd like to vote for Ananda Runs, if you're a long distance endurance runner, you can vote for them, like the post, like the pinned comment. Look cool. It was, I think communities based around physical activity is interesting, like the data you can compare and add. So definitely, I'm not an endurance runner or a sprinter. So
well, I would say I'm a short distance endurance runner. But I think on this Ananda app, I could follow and aspire to reach other and see other endurance runners and try to one day reach that.
Yeah.
reach that distance of beyond a quarter mile.
And it'd be cool to see how they compress the data for different points, because you get not only is it noisy, the GPS data, but it's also just a lot of it. So it'd be cool to check out the algorithm. All right.
Yeah.
Ben, is it any closing comments on the Chicago projects?
No, we're excited over here to be to have nailed it.
Okay. All right.
That's it. That's our closing.
Okay. Very nice work, Chicago.
All right.
Great to see all the stuff that cool stuff that
Great
you're working on.
projects. Yeah.